Okay, guys, welcome back. So when it comes to Gaussian elimination, or it comes to really just trying to solve systems where I have three equations and three unknowns, we can have a unique point of intersection. That's the first one we looked at. We can have a line as a solution. That's the last one when we have our equation or our solution in terms of a parameter. And the third possibility is that I have no common point of intersection whatsoever. Just kind of scroll down and show you guys what that looks like. That'll look something like this, which is a bit of a messy picture to kind of show like a 2D version. As if I was looking at the front of it, essentially have a triangle where these 2 points will intersect, these 2 points will intersect, these 2 points will intersect, but there's never a spot where all three intersect. So if this is true, there is some planes that are crossing over with other planes, but because not all three will intersect, there's no solution for the three equations. So therefore, in a situation like this, there will be no common point of intersection between all three. That's what we're kind of trying to look at in this example here. So I know if I have a unique solution, if I go through and do my Gaussian elimination, I can solve for Z, I can then sub into solve for Y, I can sub into solve for X. If I have infinite solutions or I have a line as a solution, then I get a row of zeros on the bottom. Well, let's have a look at what happens to my matrix if I have no common point of intersection, and how can we identify that based on our matrix? So the first step is going to stay the same. Build my augmented matrix. Step one is still going to be to make this zero. And again, they have the same number here. So we'll make this zero. We'll also make this zero at the same time. So if I redraw out my matrix, I'm going to have my new row 2 is going to be equal to, let's do row 2 minus a half row 1. And my new row 3 is going to be equal to row 3 minus a half row 1 as well. So if I go ahead and do that, that's going to become 1 minus 1. That's going to give 0. Then I'm going to have minus 1 minus a half. It's going to become minus 3 over 2. And then also I'm going to have 1 plus a half, which is going to become, well, 1 should just be 3 over 2 positively. I also am going to have 3 minus a half. That's going to become 5 on 2. Doing my third row, again, I'm going to get 0. Then I'm going to have 5 minus a half. That's going to become 9 on 2. And then I'm going to have minus 5 minus a half. That's going to become a negative 9 on 2. I also have 2 minus a half. So that's going to become 1.5 or 3 on 2. So I've got my new rows. Now I just have to eliminate this term here. And again, I want to do that using my row 2. So if I go ahead and do my matrix again, and now I'm going to have my new row 3 is going to be equal to my original row 3 plus 3 times row 2. If I go ahead and do that, that's going to become 0. I have 9 over 2 plus negative 9 over 2. That's going to give 0. Negative 9 over 2 plus 9 over 2 is going to give 0. And I have 3 over 2 plus 15 over 2, which gives 18 over 2 or 9. So what I have now on my bottom line, where I have 0, 0, 0 is 9. Well, to put that into context, that's 0 lots of x plus 0 lots of y plus 0 lots of z equals 9. That is mathematically impossible. There's no values for x, y, or z that can satisfy this system of equations. So therefore, no solutions for x, y, and z. Therefore, no common point of intersection. No common point of intersection. Again, if you look at what this looks like, it essentially is a triangle, except imagine like a triangular prism where I have this point here, and this point here. I'll kind of show you what I mean by it being like a triangular prism in 3D space. These points intersect, but there's no point where all three of those planes intersect. So again, the equations represent 3 planes that do not have a common point of intersection. That is the geometric interpretation of this solution. So I right now have a few different options for my matrices. I can do Gaussian elimination, and I can wind up with unique solutions. I can wind up with a row of all zeros. That means I have infinite solutions. Or I can wind up with a row of all zeros that equals a whole number, which is impossible. So therefore, I have no solutions.